So here's our capital allocation line, right? 5% expected return, this is our risk-free rate. Here is our risky asset right there with a, I'm sorry, this is our risky asset right here with a 22%, I think it was, expected return, 34.29% standard deviation, okay? So there's our risky asset, our risk-free asset. Capital allocation line is all the points that have a combination of some money in the risk-free assets, some money in the risky assets. That's our capital allocation line, this line. Now, suppose we are professional investment managers and we only have two assets that we're working with. We have a risk-free asset and we have a risky asset. But we can combine them together. We have a customer comes into our store and says, I would like you to make an asset for me. And the asset I want you to make for me has an expected return of 15%. In fact, this investor's name is Liza. And Liza says she wants us to make her an asset with an expected return of 15%. Can we do that?
Yes.
Okay, how do we do this? We put some of the risky asset and some of the risk-free asset together into the investment. Now, what is our formula for the expected return of a portfolio? The expected return of a portfolio is going to be equal to the risk-free rate plus the weight on the risky asset times the risk-free rate, or sorry, times the expected return of the risky asset minus the risk-free rate, right? And that was equation 1A. There was also equation 1, which would give us the same bit of information. So what Liza wants is this is what Liza wants right there, okay? Liza wants an expected return of 15%. So we plug in here 15%, that's what she wants. Our risk-free rate is 5%. Our expected return on our risky asset is what? 22%, and the risk-free rate is 5%. So this is all 17%. I have one equation with one unknown. I just need to solve for W. W is going to be the weight on the risky asset. And if I do that, the weight on the risky asset...
0.58.
58%.
58.8.
I hear a bunch of different numbers, so let me look it up, what I've got here. It's going to be equal to, 58.82%. Yeah, 58.82%. So W is going to be 58.82%. So I'm putting about 59% of my money into the risky asset, and the rest goes into the risk-free asset. Okay? So that's solving for W. Because the weight on the risk-free asset is simply going to be 1 minus W. Okay? So that's going to be solving for W. So I can put this together for Liza. So I put 58.82% of her money into the risk. So if Liza gives me $100, I invest $58.82 into the risky asset, and then I'll invest what, $41.18 into the risk-free asset. Now, Liza leaves, and she's very happy with the investment I've put together for her. And in comes another investor after Liza leaves, and this investor's name is Barb. And Barb has a little bit different preference. Barb wants me to put together an investment that has a 30% expected return. Now remember, I've only got two assets I can work with. I've got my risky asset, which has an expected return of 22%, and my risk-free asset, which has a guaranteed return of 5%. But Barb wants an expected return of 30%. Can I do it?
So we have to borrow money then.
Exactly. I'm going to end up borrowing money. But I use the same formula here. Okay. So let's erase this here, and let's erase here. And the expected return on the portfolio that Barb wants is 30%, and it's the exact same formula. Okay. but now the weight on the risky asset
147.
for Barb,
146.
147.06. 147.06%. Now, that tells, so if that's going to be the weight on the risky asset, what's 1 minus W going to be equal to?
So minus
Negative 47.06%. Okay? So this tells us this. If Barb comes in with $100, I'm going to take her $100, and where am I going to invest her $100? In the risky asset. But then I've also got to go and borrow $47.06 at a 5% rate of interest, and I invest that also into the risky asset. Okay? So I take all of Barb's money, put it into the risky asset. I also take an additional $47.06 that I have borrowed at an interest of 5% and put that into the risky asset as well. So the total proportion of Barb's money that is in the risky asset is 147.06%. The proportion of Barb's money that is invested into the risk-free asset is negative 47.06%. Because when you borrow money, that is the opposite of investing money. So it is the negative of investing money. So if investing money is a positive, borrowing money is a negative. And this will give Barb an expected return on her portfolio of 30%. That if everything goes as expected and she earns 22% on the risky investment, she pays back the 5% that was borrowed, okay, on the $47.06, she's going to end up with a 30% rate of return. Okay, and you already learned how leveraging works in your prior finance class, right? Okay, does everybody need to go back over another example of that at all? Okay, if you do at any point in time with these things, if there's any things that I say you guys have probably learned before and you want to review it, let me know. I'll be happy to review it, no problem at all. But if it seems like everybody knows it, then we'll just kind of go on from there, okay? So you can borrow money, and when you borrow money or leverage, it gives you a higher expected return. But what else does it give you a higher? A higher risk is measured by our standard deviation. Because now for both Liza and Barb, we can figure out what their standard deviation is. Because we know the standard deviation for the portfolio is equal to the weight on the risky asset times the standard deviation of the risky asset. Standard deviation of the risky asset was 34.29%. And for Liza, the weight on the risky asset, what was it? 48? No, 58, yeah, 58.82%, okay? So 58.82% times 34.29%,
20.1% standard deviation.
that's going to give you the standard deviation for Liza. For Barb, we're going to not multiply 58.82%, but we're going to multiply 147.06% times 34.29%, which is going to give it a much larger number. It looks like it's somewhere around 50% there. What is
Yes, sir,
it?
50%.
Is it 50%?
Yes, sir.
50.43%, yeah. So that's going to be 50.43% for Barb. So clearly, Barb is getting a higher expected return. Barb is also getting a higher standard deviation. Which means if things go well for Barb, she's going to be very happy. If things go poorly for Barb, she's going to be very sad, okay? Because she's got a very big standard deviation, means she could end up getting a very low return. Because remember, what we're talking about on this, okay, is we're talking about a normal probability distribution. So we're saying this is our expected return right there, and that the returns could be really high, the returns could be really low, but the expected return is in the middle. Now for Liza, they could be kind of high, kind of low. For Barb, they could be much higher and much lower. So Barb has the potential to lose a lot more money, but as a result, Barb's expected return is much higher than it is for Liza, okay?